Okay, since posting the first two videos in the trade chapter, there's a few other questions that sort of have come up, and I just want to cover this very briefly so you're familiar with it. So previously we looked at units in terms of trying to determine absolute valid advantage and comparative advantage, and should two parties trade with one another. What I want to do now, though, is I want to look at time. So in this problem, what we have is the time needed to produce 1 unit of an output. Okay, so let's make our outputs, I don't know, how about coffee and roses. Okay, so we'll take two people, we'll just make it Bob and Sue. It's trade, so we could choose nations, but since this is a micro class, I'll stick with something micro and we'll make it Bob and Sue. Okay, so let's make it, I don't know, 3 and 6 and 6 and 4. How's that? Okay, now here's the difference, and pay attention to this. These are not units, these are hours. Okay, so what I'm going to do is I'm going to make the same matrix over here. So it's the same matrix that we used for the last time, where absolute advantage goes here, comparative advantage goes here. That's left blank. Our two outputs are coffee and then roses. And now we have to decide who has, absolute advantage, comparative advantage, but based upon time. So absolute advantage. Who has the absolute advantage in the production of coffee? So recall, this is time, not units. So it takes Bob 3 hours to make a unit of coffee, and it takes Sue 6 hours to make a unit of coffee. And remember, absolute advantage is who can make the most. So in any given time frame, right, Bob is always going to be able to make more, right? Because in 6 hours, Sue will only make 1 unit, Bob will make 2 units. So Bob has the absolute advantage in terms of production of coffee based upon time, right? Well, let's look about what about roses, okay? It takes Bob 6 hours to make 1 unit of rose, and then it takes Sue 4 hours. So it takes Sue less time to make. So Sue would have the absolute advantage because she's always going to be able to make more than Bob, okay? Now, what about comparative advantage? Well, what we have to do is we have to figure out the comparative advantage, but all we're going to do is really translate the time into units, okay? So in Bob's case, right, so this is Bob. Bob, it takes Bob to make 1 unit of coffee, it takes Bob 3 hours. To make 1 unit of roses, it takes Bob 6 hours. Okay, so you can kind of see where this is going, right? In 6 hours, Bob can either make 1 unit of rose, or 3 goes into 6 2 times, 2 units of coffee. So Bob's comparative advantage is 1 rose equals 2 coffee, or 1 coffee, right? 2 divided by 2 is 1. That's going to be half of a rose. So that's Bob's comparative advantage, or opportunity cost in terms of the production of roses and coffee. What about Sue? Well, for Sue, 1 unit of coffee takes 6 hours, and 1 unit of roses takes 4 hours. Okay, so this one, it was easy because 3 and 6 sort of go in together, but what is the smallest number that both 6 and 4 go into? Well, let's just say 12. So in 12 hours, Bob can either make 6 goes into 12, 2 units of coffee, or 4 goes into 12 3 times, 3 units of roses. Again, if we just reduce down, so 1 unit, right? 2 divided by 2 is 1, 3 divided by 2, and then to reduce down to 1 rose, 3 divided by 3 is 1, and then 2 divided by 3, coffee, and there is Sue's opportunity cost. Okay, so now let's just look at roses. Who has the comparative advantage, the lowest opportunity cost? Well, Bob, to gain 1 unit of rose, has to give up 2 coffees, but Sue, to gain 1, only has to give up less than 2/3 of a unit. So it's got to be Sue with roses. What about coffee? Bob only has to give up half a rose to gain a coffee. Sue has to give up more than 1.5 roses. So for coffee, it's going to be Bob. And now that we have the matrix figured out, it's easy to answer questions like, Bob has a comparative advantage in coffee. Sue has an absolute advantage in roses. If they were going to specialize, Bob would only produce coffee, Sue would only produce roses. And that's how that works, okay? So that's number 1. Actually, I'll stop here and then I'll give you the other one